Okay, the first thing I'm going to do is give you a minute to copy down these logarithm rules. These are the rules that we are going to use in order to solve the problems in 9.5. Okay, so those are the rules that we're going to use to solve these problems. So number one, you have log base 9 of 9 times 81, and it wants us to express this as a sum of logarithms. So this is going with that top rule, right? Do you see how this is the same thing as that rule number 1? So I can rewrite this and express it as the sum of the two logs. So you'll have log base 9 of 9 plus log base 9 of 81. So this is your answer. So just on this one, just to show that this isn't just something I'm throwing out there, let's see what those both equal. First of all, in here, 9 times 81 is 729. So this is saying log base 9 of 729. And remember how to find that logarithm. What are you asking yourself? 9 to what power is 729? So let's see. 9 to the first is 9. 9 squared is 81. 9 to the third power is 729. So that logarithm is 3. Let's see what this one is. What power do you have to raise 9 to in order for it to be 9? The first power. Plus, what power do you have to raise 9 to in order for it to be 81? The second power. 1 plus 2 is 3. So they really do equal and mean the same thing. Okay, but this is your answer right here. It said to express it as a sum of logs, which is log base 9 of 9 plus log base 9 of 81. All right, number 2. Express this one as a sum of logarithms, which means if I'm going to rewrite this as the sum of the two logarithms, that says d times f in there. So I'm going to just have ln of d plus ln of f. All right, number 3 says to express as a product. You've got log base n of y to the 20th. So expressing this as a product is using that rule where you're going to bring down the exponent and make it times the log, right? That makes it a product. So let's see, what is that going to be equal to? 20 times log base n of y. Express as a product. So it's going to be the same rule as that last one we did. When it says to express as a product, that means to bring the exponent of that log down and make it times the log. So we have ln of the 6th root of 7. So what is the exponent? I don't even see it yet. Remember, we did a little bit of this in the last class. I need to turn that radical into the exponent. What does it mean if you're taking the 6th root of a number? That's the same thing as raising it to the 1/6 power, right? So this is the same thing as saying ln of 7 to the 1/6 power. Now I can express it as a product by bringing down the exponent, which will be 1/6 times ln of 7. All right. Numbers 5 and 6 say express as a difference of logarithms. So that was 4. This is 5. Log base t of p over 9. So it's written as a quotient and asking me to express it as a difference. So do you see in the quotient rule, when you have one over the other, you can express it as log of the top minus log of the bottom. So I'm going to have log base t of 9 minus log, oh, no, sorry. What's this one need to be? P minus log base t of 9. Number 6, express as a difference. You've got ln of m over n. So if I express this as a difference, I'm going to have ln of m minus ln of n. Number 7, rewrite as a sum of logs. So let's see what we have on this one. I've got log base d x to the 8th, y to the 8th, z. So these are all, there's 3 factors in there. So I'm going to express as the sum of those 3. So let's see, I've got log base d of x to the 8th plus log base d of y to the 8th plus log base d of z. So this one actually has one more thing I need to do. What do you do when your log has an exponent? Bring it down in front of the log and make it times. So these exponents come down. So you're going to have 8 times log base d of x plus 8 times log base d of y. And since this one didn't have an exponent, you're just bringing it down. Plus log base d of z. Number 8. Number 8 says express as a sum and differences of logs. So let's see what that looks like. We've got log base b So let's see. They're all going to be log base b. These are going to be the sum ones. These are going to be the ones that you're adding. What's in the denominator is what is the difference. That's because this is what you are dividing by, right? So that will be your minuses. So let's see. If I write that all out, I'll have log base b of p to the fourth plus log base b of q to the sixth. And then you subtract the denominators. So minus log base b of m to the fourth minus log base b of b to the eighth. So now what needs to happen? Bring down all the exponents. So here I've got 4 times log base b of p plus 6 times log base b of q minus, bring down the 4, log base b of m minus 8 times log base b of b. Now, look at this bottom rule, this identity rule. Remember, if these two things are the same, this whole thing is equal to 1, right? Because what do you have to raise the b to in order for it to be b? 1. So this right here really says minus 8 times 1, which just makes it what? Minus 8, right? So this right here at the end is just going to be minus 8. You'll see that here in this other identity rule that I put up here. If you have the log and its base and this are the same thing, and it has an exponent, this whole thing just turns into whatever that exponent is. So that's what happened right here, because this really says, since that's the k comes down, so you really have k times 1, which is just that k. So same thing here. This 8 came down, but since it was 8, this whole thing, log base b of b is 1, so minus 8 times 1, so that just kind of falls off, and it's just minus 8 there at the end. Go with me? Number 9. Expresses sum and differences. You've got ln of 4 over 9x to the 9th y. So again, everything that is below the division line is your quotient, which means what you're turning those into is subtraction. So you're going to have ln of 4 minus the rest of the factors are in the denominator, and there's 3 factors down here. So minus ln 9 minus ln x to the 9th minus ln of y. So this one, the only exponent that needs to come down is that 9. So I've got ln of 4 minus ln of 9 minus, bring down my 9 times ln x minus ln y. Number 10. log of the square root of c to the 9th d. So the first thing I'm going to do is turn that square root into the 1/2 power, right? That's the same thing as the square root. It's raising all that to the 1/2 power. So that'll look like this. Log of c to the 9th d all to the 1/2 power. So now I'm going to use that exponent rule that says anything that is being raised to more than one exponent, what does that exponent rule tell you to do to those exponents? Multiply them together. So let's see what that turns these into. So I have log, then I'm going to have c. If I multiply those exponents together, I have 9 times 1/2, which just gives me 9 over 2. So the c's exponent is going to be 9 halves. What is this turning into? Sum, right? Here, we can do this in 2 steps. So the d's exponent is going to be what? Just 1/2. So now, since this, what is this turning into? Since it's multiplication, since it's product, I'm going to turn it into adding those together. So I'm going to have log c to the 9/2 plus log d to the 1/2, which means what's my last step? Just bring down your exponents. So I'm going to have 9/2 log c plus 1/2 log d. Hmm? 10. All right, 11. It's going to be like this, just a lot more. Log base b. Log base b of the 4th root of m to the 12th, m to the 16th, over b to the 3rd, c to the 3rd. So just like the last one, the first thing I'm going to do is, instead of all of this being in the 4th root, I'm going to raise all of this to the 1/4 power. Right? So I'm just turning the radical into that exponent. So I've got log base b. Everything in here, m to the 12th, m to the 16th, over b to the 3rd, c to the 3rd is all being raised to the 1/4 power. Also, just like the last one, I'm going to use the exponent rule, where I multiply the exponents together. So let's see what that's going to do. I'm going to have log base b. Let's see what the m's exponent is going to be. You're multiplying all the exponents times that 1/4. So let's see. You have 12 times 1/4. So what is that going to give you? 12 over 4, which is 3. So that turned this m to having the 3rd power after I multiply the exponents together. Now the n. Its exponent is 16. I'm going to multiply it times 1/4. So I've got 16, or 16 over 1, times 1/4, which gives me 16/4, which is 4. So the n's exponent, after I multiplied those together, gave me n to the 4th. The denominator, I'm going to have b. Let's see, I'm going to have its exponent, which is 3, times 1/4. Straight across on top and bottom gives me 3/4. This time it just doesn't reduce. So I'm going to have b to the 3/4. And c, same thing, right? 3/4. Now I can write it as a sum and difference. So the top will be the adding ones minus the denominator. So what is this going to start off with? Log base b. M to the 3rd plus log base b n to the 4th, and subtract the denominators. I'm going to have minus log base b of b to the 3/4 minus log base b of c to the 3/4. So this right here, that should stick out because it's log base b of b. So let's worry about that. Let's think about that when we get there. I'm in the step now where I'm just bringing down my exponents. So now I'm going to have 3 log base b of m plus bring down the 4 log base b of n minus, what's this whole situation about to be? 3/4, just 3/4, right? If you've got log base b of b, these two things are the same. This whole thing just turns into whatever that exponent is. So minus just plain 3/4. And then bring this one down. Minus 3/4 log base b of c. Unfortunately, that is not multiple choice. Some of these are multiple choice, but this one is not. So you're going to have to type all this mess in. All right, now we're going to be going the other direction. Starting with number 12, it says log base b of 19 plus log base b of 27. And this one says to express it as a single logarithm. So I'm going the other way. What does this turn into? If they are being added together, that's the same thing as saying the single log would be log base b multiplied. Good. So you're going to have log base b of 19 times 27, and then just multiply the 19 and 27 together. So that gives you log base b of 513. 17. And that was 12. 13. Okay, number 13. Express as a single logarithm and, if possible, simplify it. you've got log of 1 million minus log 10. So since it's minus, what is going to be the single logarithm that you're going to turn it into? What does minus turn into? Division. So it's going to be log of 1 million over 10. And I can simplify this, right? If you're dividing 1 million by 10, you're essentially, when you divide by 10, you just take away a 0. Okay, so this is going to equal log. If I take away a 0, that's going to turn into 100,000. So that's going to be the first part of the answer. So log of 100,000, and then it's going to say equals what? I can just type that in my calculator, right? I hit the log button, type in 100,000. It's going to tell me 5. Why is that? What is the base if you don't see it? 10. 10 to what power is 100,000? 10 to the 5th. Number 14. Express as a single logarithm and simplify as possible. So I've got 1/3 log base b of x plus 4 log base b of y minus 2 log base b of x. So this one, we were going to do something a little bit different because we haven't seen this yet. These are like terms, right? They're both log base b of x, log base b of x. So I'm going to put those together. So I've got 1/3 of them here minus 2. So that's what I need to figure out first. What is 1/3 minus 2 over 1? So since I am subtracting, I do have to get a common denominator. The common denominator is 3. How can you turn this into a 3? What do you need to multiply it by? 3. I got to do it on top and bottom. So now I have 1/3 minus 6/3, which gives me negative 5/3. So I've got 4 log base y minus how many log base b's do I have, or base b of x? Oh, whoa. Log base b of y. Then I have minus 5/3 log base b of x. All right, so I'm going to go backwards with these. I'm going to put these back in the exponents. So let's see, I've got log base b of y to the 4th minus log base b of x to the 5/3. So what does minus, if they're both log base b, what does minus turn into? If I'm going to turn that into a single logarithm, it's going to be log base b, this over this. Yeah. So log base b, the top will be y to the 4th, and the bottom will be x to the 5/3. From when I did 1/3 minus 2. So I turned the 2 into 6/3 because that is 2, right? But now I can combine it with this because they have the same denominator. Yes. So that's why it's minus right here. All right, 15. First thing I'm going to do is turn that square root into a 1/2 power. So I've got ln of x to the 6 minus 2 ln of x to the 5th to the 1/2. So right, all I've done is turn this square root around the x to the 5th to raising it to the 1/2 power. Now I need to multiply those exponents together. So I've got ln x to the 6 minus 2 ln x. What happens when you multiply 5 times 1/2? 5/2. So these are actually like terms. So I can combine them. What I've got to do is bring down their exponents here. So I'm going to have 6 ln x minus. What do you get when you bring down this exponent? You're going to have to multiply it times this 2. So I've got 5/2 times 2/1, which gives me 10/2, which is just what? 5. So bringing down this 5/2 means I'm going to have to multiply it times that 2, which I did over there, which leaves me with 5 ln x. So I've got 6 ln of x here minus 5 ln of x there. So how much do you have? 1 ln of x. All right, the last two are not too bad. All right, so simplify the expression. When it says simplify, it's asking you to, first of all, turn it into a single logarithm. So what does a minus turn into if you turn it into a single? This one over this one, right? It turns into the quotient. So I'm going to have ln of x squared plus 9x plus 18 over x plus 6, and then I need to see if this simplifies, which means I need to factor in the top. Because if one of the factors is x plus 6, it'll cancel the x plus 6 in the bottom. So let's see, ln x and x for x squared, factors of 18 that add to 9, so plus 6 plus 3, over, just bring down the x plus 6. So there's your canceling. So all you're left with is ln of x plus 3. Last one. Very similar to this one. Log of x squared minus 4x minus 21 minus the log of x squared minus 9. So once again, since it is subtraction, I want to turn it into a single logarithm and then see if I can simplify it. So what is the subtraction going to turn into? This, good, over this. So log of x squared minus 4x minus 21 over x squared minus 9. Let's see if I'm going to be able to simplify this. These are going to have to factor and have a factor that cancels, right? So let's do the top first. Again, x and x for x squared. Factors of -21 that add to -4 will be, let's see, I'm going to use the 7 and 3 factors of 21, right? I need those to add to -4, which means you need a -7 and a +3. The bottom, I can factor here too, right? That's a difference of perfect squares. So x and x gets you x squared. And what are you going to have? Plus and -3. So your x plus 3's cancel. So what are you left with? The log of x -7 over x -3.